Hello and welcome to Lesson 1 of Python for Musicians, a Python tutorial series aimed at musicians of all levels. In the last lesson, we covered setting up Python environments on our computers and how to manage project files. We also went over some prerequisites and the best practices that we'll be following. I'm actually recording this introduction while editing the upload because I've decided to split the plan for the Lesson 1 into 2 lessons. So in this lesson, we'll be covering lists, what they are, and how to use them, and NumPy arrays and why they're better for our applications. So diving straight in, what is a list? Well, at the most fundamental level, it is an ordered collection of items. To your computer, what that means is it's a type of data that can hold other types of data. It can even contain another list. In Python, lists are also mutable. When we say that an object is mutable, it means that it can be reconfigured after it has been created, meaning we can reorder the items in the list, we can add new ones, and we can remove some, while keeping the list the same list. Let's show all of this in a new lesson project. Okay, so the first thing we're going to do is create a new project repository for lesson 0. So I'm going to go ahead and inside Python for Musicians, going to just create a new folder called Lesson 1. And then I'm going to open both Lesson 1 inside my IDE and inside my terminal. A very easy way to do this typically is to drag and drop. And then in the terminal, remember from lesson 0, I'm going to type cd space and then drag and drop the folder in there again. And then hit enter. And then we're there. Now, the last thing we need to do is activate our Conda environment. If you don't know what that is or you don't have one set up, please refer again to lesson 0 where we have set up our Conda environment. So to activate it, Conda activate and then the name of the environment that we created. In our case, it was Python for Musicians. And there we go. You should be inside lesson 1 in the Conda environment Python for Musicians. So let's create a new file. And I'm going to save it directly and call this one lists.py. Again, it's called .py to tell your computer that it's a Python file. So let's dive straight in. As per our best practices, we are going to put all our code inside an if name main statement. And the way you write that is if underscore underscore name underscore underscore equals equals. And then inside the double quotes underscore underscore main underscore underscore. And then I am going to use a function called main. And then here I'm going to say def main. And now we're going to start our coding. So let's create a variable. And this is going to be our first list. And I'm going to call it instruments. And the way to define a list in Python is to put it in square brackets. So this is now a list and it's empty. And we can populate this list with some instruments. So I'm going to populate it with a piano. And then to separate the elements in the list, you use just a comma. So a piano, a guitar, and a violin, a oud, and an OB6. But lists don't have to have the same type of element. In this case, we've used strings, and each item here is a string, but this doesn't have to be the case. For example, I can create a big mess, and it's also going to be a list, but the first element in this list is going to be 20, but as a string. The second element is going to be the integer 5, then 98.5, and then let's say a boolean is also in here. But lists can also contain other lists, and I am going to put in the instruments list that we have just created inside this big mess. Now, once we have our lists and we understand how to create them, how do we access elements within this list? The way to do that is with square brackets, but after the variable name. For example, let's print out the first element of instruments. So instruments, open bracket to say which element I want. And I'm going to put here 1. I'm going to save, and I'm going to type Python lists.py. And this here brings us to the first important lesson about lists. Lists in Python are indexed starting 0. What that means is that to access the first element of our list, in this case piano, we need to have said instruments 0 and not instruments 1, because the output we got here was guitar, which is the second element in our list. So let's show this. Save, run again, and there we go. Here's our piano. As another example, let's print out the third element of big mess. So big mess, and then in the square brackets 2. Save, run, and there we go. We have printed 98.5, which is the third element in big mess. We can also easily access the last elements in our lists. For example, say you don't really know how long your list is, but you want to access the last element in that list. You can do instruments, and then the last element from that list is -1. This logic also works for all the other elements in that list. So if -1 is OB6, -2 would be the oud, -3 would be violin, and this keeps going in that direction. So let's test this with instruments -1, save, run, and there we go. It has printed OB6. Now, remember that we can have lists inside of lists. Let's say, print me the fifth element of big mess, and then I give it yet another square brace, and I type here -2. What do you think will happen? Typically, this won't work, but in this case it will. Let's see why. When I run it, it has printed out oud. Can you see why it has printed oud? If you can't, here's why. Index number 4 in big mess is instruments. And so what has happened is that big mess, square brackets 4, is now instruments. And so we can put new square brackets after it because this now is also a list. So we are now accessing the -2nd item inside the instruments itself, which is inside big mess. And that's why we have gotten oud. We can also access more than one element at a time. For example, let's go back to instruments, and let's say I want to access guitar and violin. A way I could do that is to say I want all the elements that are between element 1 and element 3. Now, why is this the syntax? So I put 1:3. And the reason the syntax is this way is because 1 is guitar, and this is inclusive in our list, and then 3 is exclusive. So 3 in this case is oud, but the way Python understands this is it says, okay, start with guitar and get to oud, but don't print oud, just print guitar and violin. And to test this, you can see that we have not just received the outputs guitar and violin, but we have received the inputs as a list. See? List, guitar, comma, violin, and then the list has ended. So remember how I said that lists are mutable? And what mutable means is that a list can be changed after it has been created. Here's an example of that. Let's say that we want to override the first instrument. So I'm going to say the 0th element of instruments, so piano here, = saxophone. So what happens if I print our list now? Python lists. It prints us the list and it says saxophone, guitar, violin, oud, and OB6. So we have replaced our piano with a saxophone. Another thing that lists can do is we can add to them. Instruments dot append. What this append does is it says, okay, add the following element to the end of the instruments list. So if I say here I want to append an accordion and I save, what we're going to get now is the same list with the saxophone instead of the piano, but you'll notice here at the end there's another element, accordion. Lists have a lot of these functions. They're known as methods. Methods typically are functions that you put after a variable name. So if you have a syntax that goes variable dot something, and then that something has these brackets here, that means that this is a method. And there are many of them for lists. I'm not going to go through every single one of them here, but I do encourage that you look them up in the documentation. Accessing the documentation is as simple as opening Google and then typing in Python list docs. Yep, so it's important to mention that you want Python, and then what in Python are we looking for, and then docs to ask for the documentation. And then I'm going to click on the first link that I get, and here we go. It says data structures. Don't be scared of this word. Yeah, it's just a way of structuring data. And then automatically here it says more on lists, and says that the data type list has more methods. For example, append, extend, insert, and each one of them has a way of using them and what they do. So now that we've had a look at lists in action, let's talk a bit about NumPy arrays. What is a NumPy array and why use it? A NumPy array can be thought of as a list with mathematical superpowers. Another reason to use NumPy arrays is that they are foundational to many other libraries, both that we would use and to the wider community. And finally, the last reason to use NumPy arrays is that they are healthier for your computer, in that they use less space and math with them is executed much faster than math with a list. Let's have a look at defining NumPy functions in Python. So before we can start using NumPy arrays in Python, we need to install NumPy inside our virtual environment. So much like how we installed Python in the last lesson, we are going to install NumPy by using conda install NumPy. Now, in this tutorial, I'm using NumPy version 1.26. If you are following along, I do recommend that you install the same version as I am going to install. NumPy equals 1.26. Hit enter, and then it is going to tell me that it's going to install a bunch of things. Proceed, yes, no, yes, enter, and then that should be done. I'm going to go ahead now and create a new file, and I'm going to save it as arrays.py. So once we've installed NumPy on our conda environment, the last step to do is to import the NumPy library inside our script. The way you do that is with the import command. So you say import NumPy. NumPy is now active in the script. So let's create an array of the numbers 1 to 10. I'm going to call this array 210, and I'm going to create it initially as a list, and I'm going to type it out manually. To convert this 210 to an array, I'm going to use the very uncreative name r for array equals numpy.array, and then in here I'm going to put 210. Now we can test this out by printing out that array statement, and let's see what it gives us. It's going to take some time, but then it's finally printed it out. Notice the difference between the print statements of arrays and lists. Arrays print without commas, where lists print with commas, looking back at the lists that we have printed at the start of the lesson. If we are going to use NumPy a lot, we don't want to be writing NumPy every single time. So we can create a shorthand. And the typical shorthand we use is NP. So instead of import NumPy, what you can say is import as NP. Basically what this tells Python is that every time I type NP, I want you to understand NumPy. So now when I type NumPy, it doesn't understand. So I need to change this to be NP. Note that it doesn't have to be NP. This can be potato and this can be potato. And this would mean absolutely nothing to Python. It would still work, for example. Works just fine. But let's stick with the general convention and just use NP. So let's do some element-wise math. I'm going to go and say that the new R array is going to equal the array that we have up here minus 1. This wouldn't work with a list, but now watch what happens. It prints out the exact same array, but every single element has been, well, 1 minus that. There are many ways to create these NumPy arrays. We don't always have to be converting a list that we have created. For example, we can use a NumPy function called NumPy linspace to create an array of linearly spaced values. Linspace takes a couple of arguments that are mandatory. It takes the starting number of our list, I'm going to say 0, and it takes the last number on your list, I'm going to say 1. By default, linspace will create you an array of 50 numbers that go from 0 to 1. I've read the documentation and I encourage you to as well. You can find it again by just Googling NumPy array functions or NumPy array linspace if you know what you're looking for. And I'm going to say that I want this linspace to create me 10 values, not 50, just 10. And I'm going to say 10. Now, if I go ahead and I print this, try and think of what this algorithm will print out. Is this what you expected? Here, 0 and then 0.1111, 0.2222, and 3333, all the way until 1. If this is what you expected, that's great. If you expected the values 0, 0.1, 0.2, 0.3, all the way until 1, then we should have either said that we want 11 numbers instead of 10, or if we insisted that we have 10 elements, then we could say endpoint equals false. And what this tells NumPy is that I want you to go from 0 to 1, but 1 is not the final number. Basically, if we had one more number, it would be 1. And so where this is going to go is from 0 until 0.9. You notice that if there was one more number in the sequence, it would be 1, but there isn't, and 1 isn't because it is not the endpoint. Here's another NumPy function that we'll be using to create certain arrays. This is NumPy zeros. And what NumPy zeros does is it creates an array of zeros. Let's say we want 10 zeros, 10, and then we can run this. And here we go. It has printed us 10 zeros in an array. Let's quickly go back to our array that went from 1 to 10. And I'm going to show you now one of the huge benefits of using NumPy. As we saw before, NumPy allows us to do math with these arrays very easily. NumPy also has built-in functions that do math on arrays on a more general spectrum. For example, let's run each element in this 210 array, which is the integers from 1 to 10, and run them through a sign function. I'm going to print the output in another array called result. I'm going to say result equals numpy dot sine for sine wave that we are going to learn more about in the rest of this lesson. And I'm going to put in here to 10. Let's print out the result. And here we go. This is sine of 1, sine of 2, sine of 3, all the way up until sine of 10. I hope that you found this lesson helpful. This was merely an introduction into lists and NumPy arrays, and we'll be seeing more of them throughout the next lessons. Next time, we'll build upon what we learned today and learn more about the sine function that we used there at the end. We'll also learn how to plot graphs with Matplotlib. If you know people who would benefit from this series, then don't hesitate to share it with them. If there is a topic that you'd like to see covered, let me know in the comments. If you'd like to follow the series and support the channel, consider leaving a like and subscribing to receive the rest of the lessons in your feed. I'll see you next time.